Frequently in inductive reasoning, you're going to be asked to find patterns. The good news is you're pretty good at it. In fact, you started using input-output tables in middle school, so you were determining expressions for terms in sequences and series. What does that mean? Basically, you were finding the rules for a pattern. So step one, you're going to identify the variable that's the input, that's the n. And it's usually, if it's in table form, it's going to be the first column. Sometimes if the table goes like this, then it's the top row. If there is no obvious value for n, so like say I just give you a list of numbers or different figures, then use the position number for n. So the first n is 1 for the first number or figure, and then n is 2, and then n is 3, etc. Then you're going to look at how the output changes as n increases. So how much does it jump by? Is it going up or is it going down? Is it changing by the same amount? So check, and if it's changing by the same amount, when you look at the ratio of the change in output compared to the change in input, it should be a constant. For example, it could, for every step you go in position, it goes up by 3, or it goes down by 2. So you're looking at a relationship between the output and the input. If it's constant, just take that ratio and multiply it by n. If it doesn't work, then you want to try a power of n, like n squared or n cubed, and that should be n squared or n cubed there. You can also try a constant raised to the n power, like 2 to the n. So 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16. Is it behaving where it's like being multiplied by 2 every time? Then that would be a constant raised to n. And for all of the above, you may need to add, subtract, multiply, or divide by a constant to get it exactly right. So you might need to tweak it, mostly by adding or subtracting a constant. And check the expressions by substituting in at least 3 of the inputs for n, and check against the output. So for a certain value of n, you should get the same output for your expression. So what does that mean? Well, let's go ahead and do an example. We've got a series here, 3, 8, 13, 18, and 23. And it's only a list of numbers, so n is going to represent the position. So we'll have position 1, we have the number 3. Position 2, we have 8. Position 3 is 13, and 4 is 18, and 5 is 23. Then you look at the difference. That one went up by 5, 5, 5, 5. So, and the input only went up by 1. 5 divided by 1 is 5. So I'm going to try and multiply 5 times the n. 5 times 1, 5 times 2, 5 times 3, 5 times 4, 5 times 5, and even 5 times n. Well, if I look at all those numbers, I've got 5, 10, 15, 20, 25, and 5n. How high are they giving me the right number? Well, I'm getting 5 here instead of 3. I'm getting 10 instead of 8, 15 instead of 13, 20 instead of 18, and 25 instead of 23. On all of these, I'm off by 2. So if I subtract 2 from all of these, I get the right answer. So my expression is 5 times n minus 2, or 5n minus 2. So if I want the next expression, I put in position 6. 5 times 6 minus 2 is 28. And then I get 33 for the next one. I could say 5 times 7 is 35 minus 2 is 33. So each term in the pattern increases by 5. That's a conjecture I can make by looking at this table. So for further reflection, we often use the ratio of the change in output to the change in input when looking for an expression. How is this similar to slope?